Use first principle to find the derivative of the following function. F of x equals to exponential x squared. F of x equals to 2 to the power of x. F of x equals to 2 to the power of x squared. To use first principle to find the derivative of the function, by definition, limit h approach 0 of f of x plus h minus f of x over h. The derivative of the function exponential x squared is the same thing as the limit h approach 0. Anywhere there is x in the function, plug in x plus h squared minus the original function. This is the same thing as the limit h approach 0 exponential x plus h minus exponential x squared over h. This is the same thing as the limit h approach 0 of exponential x squared plus 2xh plus h squared minus exponential x squared over h. This is the same thing as the limit h approach 0 exponential x squared times exponential 2xh plus h squared minus exponential x squared, because the aim is to factor out exponential x squared. This is the same thing as the limit h approach 0. Exponential x squared is common, exponential 2xh plus h squared minus 1 over h. Limit h approach 0 of this expression is the same thing as exponential x squared, the limit h approach 0, exponential 2xh plus h squared minus 1 over h. Because there is no term with h here, it can be factored out. From this expression, let u equals to 2xh plus h squared. This is the same thing as exponential x squared, the limit h approach 0, exponential u minus 1 over h. Exponential x squared, the limit h approach 0, exponential u minus 1 over h, multiplied by 1. This special one is going to be u over u, h approach 0, exponential u minus 1 over h, multiplied by u over u. The same thing as exponential x squared, exponential u minus 1 over u, because there is no term with h here, limit u approach 0, multiplied by u over h. This is the same thing as exponential x squared. This limit is 1 from standard limit. The limit h approach 0 of exponential h minus 1 over h is 1. So this limit is 1. So the limit h approach 0 of u over h. This is the same thing as exponential x squared, limit h approach 0. What is u? From above, u is equals to 2xh plus h squared over h. So this is the same thing as exponential x squared, the limit h approach 0. H is common, 2x plus h over h. H will go away with h. Then exponential x squared, the limit approach 0 of 2x plus h. Limit of sum is sum of limit. From here, there is no h here. anytime with plug in h equals to 0, 0. There is no h here. The limit h approach 0 is still 2x. There is h here. Here will goes to 0. So the limit h approach 0 of 2x plus h is equals to the exponential x squared 2x plus 0. This is exponential x squared multiplied by 2x. So f prime of x is equals to exponential x squared prime 2x exponential x squared. Given the function f of x equals to 2 to the power of x, to use first principle to find the derivative of this function, f prime of x is the same thing as 2 to the power of x, which is the same thing as anywhere there is x, plug in x plus h. 2 to the power of x plus h minus the original function over h. This is the same thing as the limit h approach 0, 2 to the power of x, 2 to the power of h minus 2 to the power x over h, law of indices. The limit h approach 0, 2 to the power of x is common, 2 to the power of h minus 1 over h. Factor 2 to the power of x out, limit h approach 0 of 2 to the power of h minus 1 over h. For any a bigger than 0, a is not equals to 1. A is written as exponentially a. So a to the power of h will be equals to exponentially a all multiplied by h. 2 is bigger than 0. 2 is not equals to 1. 2 to the power of h is equals to exponential h in a. But from here, 2 to the power of x, the limit h approach 0. 2 to the power of h is exponential h in a minus 1 over h. Let u equals to h in a. From the above, 2 to the power of x, the limit h approach 0, exponential u minus 1 over h. U equals to h ln a. What is going to be h? H will be equals to u over ln 2. This is the same thing as 2 to the power of x, the limit h approach 0, exponential u minus 1 over u over ln 2. Everything has been changed to u here. Here will now be the limit as u approach 0, exponential u minus 1 over u over ln 2. This is the same thing as 2 to the power of x, the limit u approach 0, exponential u minus 1 divided by u over ln 2. U over ln 2. This is the same thing as 2 to the power of x, limit u approach 0, exponential u minus 1 multiplied by ln 2 over u. 2 to the power of x, limit u approach 0, exponential u minus 1 ln 2 of x, limit u approach 0, exponential u minus 1, standard limit. This is equals to 1. This is the same thing as ln 2, 2 to the power of x. So the derivative of the function 2 to the power of x is the same thing as d of the function 2 to the power of x is equals to 2 to the power of x ln 2 equals to 2 to the power of x ln 2. Use first principle to find the derivative of f of x is equals to 2 to the power of x squared. To use first principle to find the derivative of this function, f prime of x equals to 2 to the power of x squared equals to limit h approach 0 to anywhere there is x plus h square minus the original function over h. This is the same thing as the limit h approach 0 2 to the power of x square plus 2xh plus h square minus 2 to the power of x square over h. We write this in terms of 2 to the power of x square. Limit h approach 0, 2 to the power of x square multiplied by 2 to the power of 2xh plus h square minus 2 to the power of x square over h. Limit h approach 0, factor 2 to the power of x square out. 2 to the power of xh plus h square minus 1 over h. Recall that 2 is equals to exponential 2. 2h is equals to exponential h ln 2. 2 to the power of 2xh plus h square is equals to exponential 2 2xh plus h square. So let u equals to 2xh plus h square ln 2. Then the limit h approach 0, 2 to the power of x square exponential 2xh plus h square ln 2. From here, 2 to the power of 2xh plus h square is equals to 2xh plus h square minus 1 over h. 2 to the power of x square limit h approach 0 exponential u minus 1 over h. 2 to the power of x square limit h approach 0 exponential u minus 1 over h multiplied by 1. This one is going to be u over u. This is the same thing as 2x squared limit h approach 0 exponential u minus 1 over u multiplied by u over h. Because here is u, the limit here corresponds to the limit u approach 0 of this expression. This is standard limit, which is equals to 1. This is the same thing as 2 to the power of x squared limit h approach 0 of u over h. This expression is 1. This is the same thing as 2 to the power of x squared limit h approach 0. From above, u is equals to 2xh plus h square ln 2. 2xh plus h square ln 2 over h. Ln 2, 2 to the power of x square, the limit h approach 0 of 2xh plus h square over h. This is the same thing as 2 to the power of x square ln 2 limit h approach 0 h 2x plus h over h. 2 to the power of x square ln 2 limit h approach 0 of 2x plus h. Plug in h equals to 0. There is no denominator that will make it undefined. This expression will be 2 to the power of x squared ln 2x. So 2 to the power of x squared ln 2x. The derivative of the function 2 to the power of x squared is equals to d of the function 2 to the power of x squared is equals to 2x squared ln 2 2x. So the derivative of the function 2 to the power of x squared is equals to d dx of the function 2 to the power of x squared. Keep the function 2 to the power of x squared ln 2 multiplied by the derivative of the power. Derivative of the power by first principle. What of if the function is 2 to the power of x cubed? By first principle, what is going to be the derivative of this function using the idea of first principle? This is keeping the function 2 to the power of x cubed ln of the base multiplied by the derivative of the power. Observation: the derivative of the function 2 to the power of x to the power of 4 by first principle, the derivative of this function d dx of 2 to the power of x4. Keep the function 2 to the power of x4 ln the base multiplied by the derivative of the power. If the function f of x equals to 2 to the power of x squared plus 2x plus 1, by observation of first principle, the d dx of the function 2x squared plus 2x plus 1 is equals to keep the function 2 to the power of x squared plus 2x plus 1 ln of the base multiplied by the derivative of the power 2x plus 2. Exponential x squared. The derivative of this function exponential x squared is the same thing as d dx of the function exponential x squared. The derivative by first principle is keep the function exponential x squared multiplied by the derivative of the power. This is the same thing as 2x exponential x squared. F of x equals to 2 to the power of x. What is the derivative of this function by first principle? d dx in the function 2 to the power of x multiplied by the ln of the base ln 2 multiplied by the derivative of the power, which is just 1. This is the same thing as 2 to the power of x ln 2. Given the function f of x equals to 2 to the power of x squared, by first principle, the derivative of this function 2 to the power of x squared is the same thing as d dx of the function 2 to the power of x squared. Keep the function 2 to the power of x squared ln of the base multiplied by the derivative of the power, which is 2x. By first principle, the derivative is 2x multiplied by 2 to the power of x squared ln 2. F of x equals to 2 to the power of x squared plus 2x plus 1. The derivative of this function is ln of the base. Keep the function multiply by the derivative of the power by first principle. Ln 2 to the power of x squared plus 2x plus 1. F of x equals to 2 to the power of x cubed plus 1. What is going to be the derivative of this function? What is going to be the derivative of this function by first principle? By idea of first principle without going the long process of first principle. Keep the function 2 to the power of x cubed plus 1 ln of the base multiplied by the derivative of the power. This is the same thing as 2 to the power of x cubed plus 1, 3x squared ln 2. Also, from the observation of first principle, given the function exponential x cubed plus 2x, given the function exponential x squared plus 2x, what is going to be the derivative of this function without using the first principle method, but using the idea from the above. Keep the function x squared plus 2x multiplied by the derivative of the power by first principle. This is 2x plus 2 exponential x squared plus 2x is equal to the x of the function exponential x cubed plus 2x. This is the same thing as the x equals to keep the function exponential x cubed plus 2x multiplied by the derivative of the power by first principle. Thanks for watching. That is all for this video. In the next video, we are going to discuss how to use first principle to find the derivative of the function ln x plus 1. Ln x is the same thing as log x to base e. Ln x plus 1 is the same thing as log of x plus 1 to base e. You are going to use first principle to find the derivative of the function log x to base 2.